Alrighty, guys. So let's go over the Hess's law problem that we did at the end of class and we ran out of time. So we got three reactions right here that are going to combine to make this reaction at the very bottom. Now, again, what we want to do is we want to make sure that the only things we have left over are these three compounds, and we need exactly the same number of moles as specified. So we want 1 mole of N2O, we want 1 mole of NO2, and we want 3 moles of NO, okay? Okay, so first thing we want to do is we want to make sure that we have all of the compounds on the correct side of the reaction. So if you notice, N2O is on the reactant side. So let's look for the equation with N2O. Okay, it looks like this reaction right here. So we're gonna have to have this reaction is fine the way it is. The only issue is we want to make sure that you only have 1 mole. Sorry, that was a bell. You just want to make sure that you have 1 mole of N2O, okay? Now, the problem is there are 2. So if we have a reaction like this, we want to make sure that we only have 1 mole of N2O. So what we can do is we can divide the entire reaction by 2. So if we divide N2O by 2, it'll give us 2. It'll give us 2 here, and it will give us 1/2 for the O2. Now, in terms of Hess's law, you can use fractions for these chemical reactions. Usually you can't, but here we can. Now, the only thing that we need to keep in mind now is we want to make sure that we want to divide the enthalpy by 2 as well. So we would take the negative 163.2 and divide it by 2 as well, and that's going to give us negative 81.6 kilojoules. Okay. So it's going to be this reaction right here. Now, again, the reason why we chose to start with this reaction is because N2O needs to be in the final reaction. And then we divided it by 2 so that we can have just 1 N2O in the final reaction like this. Okay. All right, let's move on to the second reaction. So pretty much we've used up this reaction. We don't need to worry about this guy anymore. Now, the second reaction we want to work with is going to be the one that has NO2. Now, there's an NO2 in this reaction right here, but if you notice, it's on the wrong side of the equation. Here, the NO2 is on the right side of the equation. We want to make sure that's on the reactant side. So what we're going to do is we're going to flip this equation. So we're going to flip it so that we have 2 NO2 on the reactant side, and we want to have 2 NO and O2 on the product side. Okay. All right, let me just rewrite this real quick so it's easier to look at. Okay, so now we have NO2 on the correct side. And since we flipped the reaction, we need to change the enthalpy. We want to change the enthalpy so that it goes from positive, or it goes from negative, and we want to turn it to positive. And that's because we flipped the reaction. Okay, now we have another problem here. In our final reaction, we only want 1 mole of NO2, but we have 2 moles here. So we're going to have to do the same thing here and divide this reaction by 2 as well. So if we divide this reaction by 2, we're going to get 1 mole of NO2, 1 mole of NO, and we're going to get 1/2 of O2. Okay. We'll also need to divide our enthalpy by 2. And so that's going to give us an enthalpy of 56.55. And we're pretty much done with this reaction. Now, for the final step, we want to make sure that we have 3 moles of NO on the product side. It looks like we already have 1 mole. We just need 2 more. So this reaction right here seems good. So we're going to put N2 plus O2. We're just going to copy it down exactly the way it is. And 2 moles of NO. And then the change in enthalpy is 180.7 kilojoules. Okay, so what we're going to do now is we're going to combine these reactions, and then that will allow us to see if we have this reaction that we're looking for right here on the bottom. Okay. Now, before we do that, what we want to do is we want to cross out everything that cancels that's on the reactant side and the product side. Okay. So let's just go down the list. So N2O, you only got N2O on the left side, so we can keep it. So we're going to keep N2O. Okay, so I'm gonna cross that out to show that we used it. NO2, we only got NO2 on the left side, so it's gonna go down to the very bottom. So NO2, let's show that we used it. Now there's an N2, 1 mole of N2 on the left and right side. So these guys are gonna cancel each other out. So we don't write them in the final equation. And then for O2, it seems like we have 1 mole of O2 here, and then we have 1/2 O2, 1/2 O2. If you combine them, it's 1. So these guys will also cancel out. Okay, perfect. So that's everything on the reactant side is used up. So we can draw our arrow. And if you notice, we have 3 moles of NO, and this is the exact same reaction that we are looking for. So there you go. This is going to be our final reaction. Okay, all we got to do now is add up the enthalpies. So we're going to add negative 81.6 with 56.55 with 180.7, and that will give us a final enthalpy of 155.65. So that is going to be the enthalpy of this reaction. Alrighty, guys. So hopefully that was helpful. If you guys have any questions, make sure you guys message me on Canvas. Let me know if you guys have any questions, and good luck working on your assignments. We'll go over Hess's law next time. So if this is still a little bit confusing to you, don't freak out too much. We'll have some time to go over it next time. All right. Good luck, guys.